Number 4, the instructions say solve the system by substitution. And so what I thought we could do is remember a little bit about this from the very basic building blocks. So I want to ask you guys a couple of questions. Question number 1, can anybody explain what is a system of equations? What is a system of equations? Yes, sir.
A set of equations that go together.
Yeah, it's a set of equations that go together. So he said a set of equations. Couldn't you say more than one?
Yeah.
Okay, so I'm going to say this. I'm going to ask that same question again, and I want you guys to respond. So I'm going to say, what is a system of equations? And I want you guys to respond to that, okay? 1, 2, 3. What is a system of equations? More than one equations, a set of more than one equations, something like that. Okay, so let me ask you a couple more questions. The next one would be this. On a graph, like if you were to graph these more than one equation systems, if you were to graph them, what does the solution look like on the graph?
It's where the two lines cross.
It's where the two lines cross. That's right. So we're going to say that together again. So if I say, what is the graphical solution to a system, you would say? Where the two lines cross, where they intersect. That's right. And so we've looked at that way of solving a system. We look for where the lines cross. That's one way. And then the other way that we've learned so far is this substitution idea. That's what we're going to review here right now. So substitution basically depends on this. We need to have one of the two equations solved for one of the variables in order to substitute. Do you see that scenario right now up there? Is one of the equations have one of its variables isolated? Yeah, which equation is already solved for something? And the bottom equation is solved for y. Okay, so what that means is very important. That means in the other equation, wherever I see a y, I can replace it with something. I can replace the y with whatever the y is equal to. So that's what I'm going to do. So check this out. In this other equation, I am going to remove the y. And I'll just put some empty parentheses right there. Equals 5. So do you see how I have removed the y from that first equation? It's gone. What is the only thing that I'm allowed to replace that y with?
The bottom equation.
Yeah, the negative 4/3 x plus 5/3. The reason I'm allowed to do that is because I know that y and the negative 4/3 x plus 5/3 have the same value. And how do I know that they have the same value? The equal sign, right? The y is by itself, and it equals that other expression. So in place of the y, I can write negative 4/3 x plus 5/3. That's the only thing that I can replace y with because that's what y equals. All right, so often with substitution, the distributive property is a thing. And do you see how the distributive property is a thing here? Do you see it? So what we're going to do is we are going to multiply the 3 times both terms on the inside. So let's think this over. 4x plus, what do you guys think is going to work out here when I multiply this 3 times the negative 4/3 x? Lana?
You have to cross-reduce the denominator on the negative 4 over 3.
And what happens with the 3's?
They become 1s.
And so the end result would be?
4. Yeah, negative 4.
Negative 4x, right? We can't lose the x. Okay. Well, I guess you can, but then it would be wrong. Okay, and then how about that other distributive property if I multiply the 3 over 1 times 5/3? Doesn't something similar happen? So Sam, what's going to result if I multiply that 3 over 1 distributed over there times the 5/3? Which reduces down to be? 5. That's right. So plus 5 equals 5. And this is where this particular question gets a little unique. If I add the like terms on the left, what is 4x plus negative 4x? What is it? 0. And what's 0 plus 5? So I would say this is strange, but we've seen this before several times where the variables simply just add out. They seem to go away, right? So in these cases, your answer is always going to be either no solution or infinitely many solutions. So what do you think is going to happen in this case?
No solution.
Why do you say no solution, Alec?
Because, 4x minus 4x is 0, and then 5 minus 5 is 0.
So that means no solution?
Oh, yeah, then it would be infinitely many.
Why?
Because 0 equals 0.
Yeah, and
5 equals 5.
5 equals 5. So if the variables, this is true of equations, this is true of systems of equations, if the variables add out, which they did, then you simply look at the truth or false of this statement, and if it's true, which it is, then the answer would be infinitely many solutions, or you could say all real numbers work. In other words, there is not a number for x or y that you plug in that it wouldn't work. All of them work. So infinitely many solutions, 5 equals 5 is an indicator of that. If we ended up with like 5 equals 10, which is false, obviously, we would get no solution. Okay. All right, so I want to give you guys a chance to try this by yourselves, totally on your own. Please try number 5. See how it goes for you. Ready, set, go. Did you all notice that there's like 2 ways you could substitute here?
Yes.
Did you notice that the first equation was solved for x, so that's good. And of course, maybe you noticed the second equation was solved for y. And so you could substitute either direction here, it doesn't really matter. Bless you. What I saw, my first instinct was using this one right here to substitute with. It seemed like it was a little simpler, but you did not have to go that particular direction. Maybe some of you went the other way, and that's fine. So if I was going to go the way that I'm intending there, what I would do is I would say, well, since y is the same value as 1/3 x, in the other equation, wherever I see a y, I can put 1/3 x. I could just replace, right? Substitute. And so if I was going to do that, here's what it would look like. 3 times 1/3 x minus 10 equals x. So notice how I've just replaced the y with 1/3 x. And I can do that because why? They're equal. They're equal to each other. I can replace one with the other. All right, so what is 3 times 1/3? It's just 1. That's right. So we end up with 1x minus 10 is equal to x. It might not be obvious at this point yet, but I do have an x on the left and I have an x on the right. So I've got some like terms I could combine, and I should. So if I've got an x on the left and an x on the right, how do I combine them? Subtraction. That's right. So I'm going to go minus x from both sides. And this is where it gets a little tricky, where people get a little like nervous and they maybe make some mistakes. It doesn't matter which side it's on. If you have 1x and you go minus 1x, how many x's do you have left?
0x.
0, and 0x is not x, it's 0. Yeah. And so x minus x is 0. You're just left with 0 minus 10, which is negative 10. And the same kind of reasoning over on the right side, x minus x is 0. So you end up with this right here, and you notice, of course, that the variables have added out. This will not always be the case, right? The first 3 examples, the variables didn't add out, and we actually got x equals 2 and y equals negative 5, or whatever. But here, the variables have added out. I get this negative 10 equals 0, and that's not true, is it?
No.
Negative 10 does not equal 0, so what is my conclusion? There is no solution. Really what this means is that there is no set of x's and y's that will work in both equations. Doesn't matter what you plug in, you're not going to get it to work in both equations ever. And so that's why there's no solution there. So let me ask you this. Let's go one extension beyond this. If there is no solution, what does that mean about these 2 lines?
They don't intersect.
They don't intersect. If we graphed them, we'd see that they are parallel. They are parallel lines. In fact, if you put the top line into slope-intercept form, you'd see the slopes are the same, but the y-intercepts are different. And so that makes them parallel. Okay, so Grace a second ago said, hey, can we practice these? And, if we do get a chance today, we will, but tomorrow we definitely will. Tomorrow I plan on spending most of our time at the board. Okay? So if you guys would, let's thumb over to the final section, the final skill here, 4.3. And this is called, maybe you've seen this before, elimination. Okay, so I thought we would review this again, because the first time I asked it, there was a little bit of a waking up period. Maybe you're still waking up. So I want to ask these questions. What is a system of equations?
More than one set of equations.
There we go. That's better. So it's more than one equation. And here in Algebra 1, we're going to limit the more than one part to just 2. We won't go 3 or 4. In Algebra 2, you might go with 3 or 4 equations. But you might learn even a different technique that might be more efficient for 3 or 4. So please don't think that all of the techniques I'm showing you here in Algebra 1 are the only techniques. There are others. These are probably the best ones for this level of algebra, for the 2 equations. So more than one equation, that's what a system is. What are the 2 methods we've learned so far? There's 2 of them. Substitution, that's the one we've been working on for the last several days. And then what was the one we worked on at the very start? We graphed the lines. Yeah, we graphed the system. And when we graphed, we were looking for where the lines intersect, and that was our solution. Okay, so we're going to learn one more method here today, and that method is called elimination. And this one, I would say, is a personal favorite of mine. If somebody gave me 10 random systems of equations, I would bet that I would use elimination on 8 of them if I had the choice. To me, elimination would probably be, and this is just my own personal opinion. You might disagree and say, no, I like substitution better. That's fine. I got no problem with that. I found that I use elimination probably more than the other methods. Okay? So I think this is a good one. So in order for this to work, we need the coefficients on one of the variables to be opposites. So I want to make sure for just a second here we clarify what opposites are. So if I asked you, what is the opposite of 7? What would you say? Negative 7. Okay, so the opposite, there we go. The opposite of 7 is negative 7. What if I said, what's the opposite of negative 4? What would you say? 4. So opposite just means the other sign, right? Let's take this to one more level, and let's look at it from this perspective. What if I gave you a term like this? What if I said negative 3x? What would you say is the opposite of negative 3x? No? What do you think?
Positive 3y.
Oh, interesting. Okay. Close. What do you think? Positive 3x. So you're switching the variable too. And so whoever said 1/3, you were doing a reciprocal. So whenever I say the opposite of something, all it means is change the sign. And here's what's so important about this. What if I took these two terms, the negative 3x and the 3x, and what if I added those? What's negative 3x plus 3x, Ashlyn? 0. Hence why this is called elimination. So what if we did a different one? What if we did, 12x? What is the opposite of 12x?
12x.
Negative 12x. You just change the sign from negative to positive or positive to negative. And what if I took 12x and I added it to its opposite? What do I get? 0. So that's the principle at play here. If you ever take some term and you add it to its opposite, you should always get 0. Make sense? Carissa, does that make sense?
Yeah.
Okay, just checking. All right, so let's look at a couple of examples here. I thought we'd start off with number 1. Yes. Okay. So in number 1, notice the directions are pretty clear. They say solve by elimination. So for those that do not have the notes packets printed out yet, this is going to get worse and worse. I promise. After Thanksgiving break, it'll only get worse because we're going to do applications. They're going to be like a paragraph. I actually might have some over here. I don't know. I do. Look at that.
Do you want to give Hosanna one? No.
Hosanna has one, right?
No. I need this one until I get mine.
Well, your journey is over.
Thank you for your charity.
I got one. You guys can share.
To make it look like you have one.
Okay, so what do you guys notice? Hey, listen. Looking at the systems, gentlemen, looking at the system up there, can you guys tell, are there any set of terms that are already opposites? What do you see, Jake? The y's, right? You've got a negative 2y, and you've got a positive 2y, and based on that pattern we just talked about, those two terms are opposite. Kind of cool. So here's what we're going to do. They won't always be this way, but we're going to be able to eliminate right away. Here's how we eliminate. We're going to do addition. So I'm just going to draw a line underneath, and I'll put a little plus sign out to the side, and all I'm going to do is just add up these equations. And as long as I combine only the like terms, I can just add the equations up. Some books, some people will call this, instead of elimination, they'll call this addition, because all you're doing is you're adding up the equations. You're adding the like terms in both equations. So here's how this works. I'm going to look at my x terms. I've got a 4x and a 3x. I'm just going to add them up. So what's 4x plus 3x? 7x. Okay. This next step is really important. What's negative 2y plus its opposite? 0. And so down below there, I'm not going to write anything because plus 0 doesn't really do anything, right? If you wanted to write that, that's no big deal. But then in the next step, wouldn't you just not write that? So up to you if you want to write that or not. I'm going to leave that off for the most part. And then 22 plus 20 is 42. I don't. Yeah, so I would write 7x equals 42. Okay, so to finish this one off, we need to get the x by itself, and that means that I need to do what? Dividing by 7 is it. So dividing by 7 gives me x equals 6. Awesome. So I know for a fact that that is not my complete answer because I know that the solution to a system is where the lines cross, right? And that's always going to be x comma y. I know that x is 6, but I don't know what y is. How can I figure out what the y is?
Plug in the 6 for X.
Same thing we did with substitution, right? You just plug it back in for x. I don't know that it's going to make a whole lot of difference as to which one I plug into. Maybe I'll plug into this one. I don't know that it's going to make much of a difference. Here's what that would look like. It would be 3 times 6 plus 2y equals 20. Simply taking that bottom equation, it would work in either one, taking the bottom equation and plugging in 6 for x, because I know that x is 6. A little bit of equation solving here. 18 plus 2y equals 20. Should I get rid of the 18 first or the 2 first? How do I get rid of the 18? Subtract the 18 from both sides. So that gives you 2y equals 2. 20 minus 18. And then to get the y all the way by itself, division by 2. And of course, 2 divided by 2 is 1. So that means that our final answer would be 6, comma 1. That's where those two lines cross. Elimination is way easier than graphing in almost every case. And in this case, I'd say it's quite a bit easier than substitution. Okay?
I agree.
All right. So, do you have any questions? Let's see what our next one is. Maybe I'll have you guys try this one. Or maybe I'll help you out a little bit. We'll see how it goes. Take a look at number 2. Okay? So with number 2,
Do subtraction.
well, okay, we could, some folks will do it that way. I personally like to add every time, and I'll show you how we deal with it. Grace, you've definitely identified a key thing. We'll talk about this, though. Guys, look at the system. Do you see opposites on the x's or opposites on the y's? No. I mean, the x's are both 6x, so that's close. The y's are 5y and 7y, so those are definitely not opposites. And so what that means is we're going to have to take a slightly different tactic here. And I want to remind you of something. If you have an equation, are you not allowed to add something to both sides of an equation? Can't you also multiply both sides of an equation by something?
Yeah.
As long as you do one thing to the left side and you do the same thing to the right side, you're allowed to manipulate equations like that, aren't you? So here's what we're going to do. I want to create the pattern of opposites. It's not there right now, so I'm going to make it. And here's how I'm going to do it. I notice the x's are already 6x and 6x. What do you think I could do to one of those two equations to create a pattern of opposites?
Times -1.
Multiply by -1. So if let's say I did that here. Let's say here would be how I would note that. Maybe I'll do the top equation. It doesn't really matter which one. I'm going to multiply the top equation by -1, and I'll write the results below. So it's really a distributive property, isn't it? So -1 gets multiplied here. That would give me -6x. -1 multiplies in there. That gives me -5y. And then don't forget, we got to multiply it onto that last one as well. What's -1 times -49? Positive 49. Okay, good. So I've written the result down below. This is typically how I'll note this. Now, when I compare these two equations, these two that I'm highlighting in red, wouldn't it be fair to say that both of those equations, when you look at them, they do have a pattern of opposites? There's a 6x and a -6x. Now, I created that by doing the algebraically allowed, multiplying that top equation through by -1. I've created the opposites by doing that. So what I'd like to have you guys do is see if you can finish this one. Ready, set, go. See if we can all agree. So what I'm going to do is I'm going to add my two equations here. So I've got 6x plus -6x right off the bat. Luke, what is 6x plus -6x? I'd really prefer that Luke think through that question since I called on him. Okay. So you think you're helping him, but you're actually hurting him. Okay. Yeah. So Luke, does that make sense that 6x plus negative 6x is 0?
Yep.
Okay, cool. Just wanted to make sure. All right, so that's 0, so I'm not going to write anything there. I know I did on the other one. I'm just not going to write anything. What about the other one, the y's? If I add 7y plus negative 5y, what do I get?
2y.
2y, that's right. Good job. And then if I add negative 59 plus 49, I get?
Negative 10.
Negative 10. Good. So then solving this, I divide both sides by 2, and I get y is equal to negative 5. So look at your papers. Is that what you've got?
Yeah.
All right, so doesn't that mean that we're like halfway to the answer? I know that it's got to be x comma y because we're looking for where the lines intersect. Y equals negative 5 is half of it. How can I find the x to go with the y? What do I do, Cole? Plug it back in. I got 3 options here, really. Here are my 3 options. I've got equation number 1, equation number 2, equation number 3. It doesn't matter which one you use, to be honest with you. So I would just go with your first instinct, what you think is easier. And Kendall, what did you plug back into, or what do you think would be easiest?
I plugged it into the top equation.
Fair enough.
6x plus 5y.
I like it. That totally works for me. So it would be 6x plus 5 times negative 5 equals negative 49.
What? Oh, I thought you meant 5 times 6. No.
And let's see here. 5 times negative 5 is negative 25. What do I need to do? Do I need to get rid of the 6 first or the negative 25 first?
Add the 25.
Yeah. Let's add that 25 over. When I add the 25 over, I get 6x equals negative 24. Finally, I've got to get rid of the 6. I get rid of the 6 by doing what? Dividing by 6. Good. Okay, so then x is equal to negative 4. So our final answer for the intersection point is negative 4, comma, negative 5. All right, so did you guys do that one okay?
Yeah.
Any questions? It's encouraging. Okay, so what I think we will do is, let's do one more. Oh, I'm sorry, you have a question?
No.
Are you sure?
Wait, for y, I got 15 over negative. I got negative 19 over 5.
You goofed.
For y
Yeah.
or
I
for
did
x?
For y.
Okay, so let's go back and trace through. Did you multiply through by a negative 1 like I did? So do you have what I have in the purple box?
Yeah, I have the negative 6x, and then I did times negative 5.
What?
Did I do that wrong?
You said times negative 5?
Oh, I put it in the wrong box. No, wait.
So what I was going to ask is, when you did your elimination, did you end up with this?
Oh, yeah, I got that. I put a x instead of a y.
Oh, got it. Yep, makes a difference. Definitely makes a difference. Okay. Any other questions or thoughts? All right. So let's see here. I think we're going to forego the table partner thing because we'll end up at the board at some point, whether that be today or tomorrow. I'd like to maybe talk this one through with you a little bit. This one is different looking, isn't it? Did you notice on 1 and 2, like all the x's were nicely lined up, and all the y's were lined up, the equal signs were, everything was lined up, wasn't it?
Yeah.
Here, not the case. So let's do a little bit of work to get things lined up. I don't know, suggestions on what you think we ought to do to get everything lined up. Victoria, what's your thought?
Move the 6. Move the negative 6.
Okay, and we do that by addition. Okay, so that would give us 5x plus 3y is equal to 0 plus 6, right? Which is 6. So that puts this top equation into kind of a familiar format. It's like what we had before. So if we're going to go that way, then I think we probably should try to make the other equation kind of fit that same format. We don't have to do, the format like we've been doing, but since she set that up, let's try this with the other one. Any suggestions on what I could do with the other one to get into that same format? What algebra step? What do you think, Grace?
I think you can subtract the 9y on both sides.
Yep. So when you subtract the 9y, you get 8x minus 9y is equal to negative 18. So we basically moved the negative 6 over to the right, and we brought the 9y over to the left by subtraction.
But there's no opposites.
We'll get there in a second, don't worry. Does this part make sense so far? In order to do elimination, that's kind of the one trick with elimination. The x's have to be lined up, the y's have to be lined up, the equal signs have to be lined up, the constants if there are any. Everything has to be lined up in its proper little spot. So you might have to move some stuff around a little bit. Okay. Does that make sense? Okay. So, Cooper, do you see some opposites up there? Do you see the x's being opposites or the y's being opposites?
Yeah, the Y's are opposite.
Not really, though, because opposites would be like 10 and negative 10,
Yeah.
or 8 and negative 8. And I see 3y and negative 9y. So they do have different signs. I'll definitely give you that. But they're not opposites yet. And so kind of like before, we need to create the opposites, don't we? Remember how last time we multiplied one of the equations through by negative 1?
Yeah.
Alec, what do we need to do here?
Times it by 3.
We need to multiply one of the equations by 3. Do I need to multiply the purple or the blue by 3?
Purple.
Purple needs to be multiplied by 3. Question? So couldn't you divide the blue one by 3?
Yeah, that's what I did.
If you did, you would end up with 8/3 x minus 3y equals negative 6. Not the end of the world. I'm also not a fan of 8/3. At working with as many algebra students as I have in the past, if I can help you avoid fractions, I will. And so, Jake, while your idea is very valid, I think that it's not probably the best idea for most folks. So I would tend to be multiplying by a number instead of dividing by a number. So I'll take the original advice and multiply by 3, because I'll have some good thoughts on this. So I'm going to multiply that top equation by 3. And so this is a distributive property. So that's going to give me 15x plus 9y is equal to 18. Why don't you guys work to finish this one out? So
You can just multiply it by any number you want.
So with an equation, as long as you multiply both sides by the same thing, you are. So notice how I multiplied the whole left side
Okay.
by 3, as well as the right side.
Yeah, okay, I understand that.
What you can't do is you can't multiply the left side by 3 and just leave the right side alone, or vice versa. You got to be consistent and multiply both sides by the same thing. What's up, Hosanna? Very careful with the details. Let's see how this works out for us. If I add these up, let's see what happens. Connor, 8x plus 15x ends up being what?
23x.
Right on the money. So 23x. We move on to the y's now. So if I'm going to try to add those y's, remember the y's were the opposites. So if you add negative 9y, Joel, plus 9y, what do you get?
0.
That's the elimination part, right? That was kind of the whole goal here. You can write plus 0 if you want, but you don't have to. Page on the right-hand side of the equal sign, what is negative 18 plus 18?
0.
This is where there's a big decision point. There's a handful of folks that as I walked around, I listened, a couple folks I talked to. This was kind of a moment of panic, right? It was like, oh my gosh, no solution, right, Mr. Anderson? No, it's not no solution. Here's why. When you look at this equation that results, would it be fair to say that there's still an x, isn't there? It's not like all the x's went away. There's still an x there. And so I need to get the x by itself. What would I need to do to get the x by itself? Divide by 23. And what is 0 divided by 23?
0.
It's just 0. That's right. So x is equal to 0. That means my point of intersection is going to be at 0 comma something. How do I find the y to go with that x being 0?
Plug in 0.
Plug it in, just like before. Plug in a 0 in for x. It doesn't matter which equation. Emily, I'll let you choose which equation.
I used the first one.
You use the first one? Fair enough. So when you say first one, are you talking about this purple one up here?
Yeah.
All right. So if we do that purple one there, we'd have 5 times 0 plus 3y is equal to 6. What's anything times 0?
0.
That's a good news here. So end up with 3y equals 6. As you guys know, we divide both sides by 3, and I get y equals 2. So my solution would be 0 comma 2. 0, 2. Okay. So guys, this puts us in a really nice spot as far as tomorrow. When you come to class tomorrow, we got a couple more examples we'll just kind of pepper in tomorrow, but mostly we will be at the board practicing. Okay? Substitution, elimination, trying to get you guys as solid as possible and thinking about your quiz on Friday. All right. Hanging it. Go. Don't pack up and go. We still got a few minutes. I'm going to hand back your benchmarks.